4.3, number 110. Find the critical values that are in the domain of the following functions. All right, so f of x in this problem is 1 over x minus 1. So if I'm going to know if the critical value is in the domain or not, I should probably figure out the domain. So it looks like the domain of f, the domain of f is everything except 1. I'm going to write it like this, all reals except 1. All right, all reals except 1. So now I take the derivative to find the critical values. And I set the derivative equal to 0 and solve for x. That's the process to find critical values. Now I should also set the derivative to undefined. So I'm going to write equal to 0 or undefined. Equal to 0 is probably the more important scenario. They're both important, but equal to 0 comes up a lot more than undefined. This one should have both, okay, to at least check on, right? To reasonably check on. So let's take the derivative. I could view this as a quotient rule. That's a bit unnecessary because I can easily do this. A quotient rule will be fine, it won't matter. It'll still give you the correct derivative, but I would prefer to view it whenever the numerator is a constant. It's usually preferable to think about it like this instead. Okay? I could use a power rule with a chain rule. So the derivative should then be negative 1 comes down. X minus 1 stays the same. This goes down to negative 2. And I take the derivative of the inside, which is just 1, and does nothing. So therefore, we should have negative x minus 1 to the negative 2, which will look better without negative exponents. You really do not want negative exponents in these types of problems. You'll get confused about all sorts of things. So negative 1 on x minus 1 quantity squared. Okay, I'll try to demonstrate right now why a person might get confused with negative exponents. All right, so let's just forget for a moment that I wrote it like this, even though this is preferable. Let's just say I kept it as what we had a second ago, right? So what not to do. So I've set negative x minus 1 to the negative 2. I set equal to 0 and try to solve, right? First thing a person says to themselves is 1. X equals 1. So what's the problem with that? Is that 1 minus 1 is 0, but 0 to the negative 2 is not 0, right? 0 to any negative exponent is not 0. 0 to positive exponents, except for 0, is 0. But 0 to a negative exponent is not 0 because when you think about it like this, written more properly, you might say, if I put a 1 in here, it does not render this ratio to become 0. So therefore, this is not how to handle this situation and how you can easily become confused with negative exponents. All right. So writing it with positive exponents is preferable because that confusion should not arise because you see it directly in the denominator. If you're thinking properly, there's no worries, but most of the time people do not think properly about negative exponents. But when they see this kind of expression, they realize immediately that 1 is not going to make this 0. What does it make it though? It makes it undefined. Okay? So there's no value that makes the derivative 0. The derivative is never 0. Okay? But the derivative is undefined. Okay? So this has no solution. But f prime of x is undefined, and this is also important, at x equals 1. Okay? So it looks like we found a critical value. The problem is that the number 1, if we look back at the domain, the number 1 is not even in the domain of the function. Nothing is even happening at 1 for this function. Matter of fact, it's an asymptote, right? There's no function values there. So it does not concern us that the derivative is undefined there. Of course the derivative is undefined there. There's no function there to have a derivative in the first place at 1. So even though it looks like a critical value, we don't really consider it 1 because it is not in the domain of f at all. So this particular problem has no critical values for f. X has no critical values in its domain. And that's really what you're worried about, is critical values in the domain. And that's why the problem is phrasing it like this.